Hi there. Let's geek out today about rational exponents. Again, none of this is required for Math 10.4.3, but I would recommend that you kind of check this stuff out. It'll help you out for Math 10.4.6 if you want to continue with that at the college. So let's take a look right now today at rational exponents. And basically what this means is what happens when we have a base, let's say 3, and we have like a fractional exponent, or maybe a variable is down here, or something crazy going on like that. That's what we mean by rational exponents. Okay, and really the play is, if we take an example right here, 125 to the 1/3 power, we can rewrite that as the cubed root of 125 raised to the power of 1. Now, how we can do that, if I go back a slide, what this means, and I'll just rewrite this, I'll put the square in and I'll put the exponent in, even though we would rarely do that. What happens here is the denominator of your fraction becomes the index of the square root. Okay, now the index is the little number right here. If it's a square root, we never ever write that because it's so common, but it could be a cubed root or a fourth root or a fifth root or whatever. Whatever the denominator is, that becomes the index. Whatever the base is, the big number, that becomes the radicand. This is the number underneath the square roots on. And whatever the numerator of that fraction is, that becomes the exponent to which the answer is raised. I spelled exponent wrong, but you guys follow me there. Okay, so what we can do here, if we have 125, and I'll just write it a little bit bigger, 125 to the third, let's rewrite that as the cubed root of 125 raised to the power of 1, which we don't even have to write. Now what the answer is 5. And when we're doing these higher order roots, what we can do is we can do a prime factorization on the number, if we don't know the answer, and we can just come up with it. So this is going to be 5 times 25. 5 is a prime number. 25 breaks down into 5 times 5. So I could rewrite 125. I could say that 125 equals 5 cubed. Right? 5 times 5 times 5. There's 3 5s here, so I can write that as 5 cubed. And if I were to take the cubed root of 5 cubed, well, the cubes cancel, so we're just left with 5. Right? That's essentially how it works. And it doesn't matter if we have a negative outside like we do here. We're just going to evaluate, evaluate the root or the exponent or whatever you want to call it, and then multiply your answer by -1. So here, if we have -16 to the 4th exponent, we'll rewrite that. We'll use brackets just to keep the negative out, but that's going to be the 4th root of 16. So again, 16, you could do a prime factorization on that. If you had no idea, well, that's 2 times 8, and 8 breaks down into 2 times 4, and 4 breaks down into 2 times 2. So you can see we have 4 2's being multiplied together, and we have the 4th index. So essentially we're taking the 4th root of 2 to the 4th power. That's how I get 2. But remember, now we have this negative out here, which really means -1 times all of this. So -1 times 2 gives us -2. Okay, that's kind of the play. If we have a negative inside the brackets, and again we covered this a little bit in Math 10.4.3, essentially we're going to do the same thing, only now the base is negative, so the radicand becomes negative. So instead of -27 to the 1/3 exponent, now it's the cubed root of -27. And remember, you can't take the square root of a negative number and get a real answer, but you can take the cubed root of a negative number and get a real answer. Again, -3 times -3 times -3 will give us -27. Hence our answer is -3. Okay? And again, it really doesn't matter. You could use variables here as well. It's the same play, all right? The denominator becomes the index, and the numerator becomes the exponent. All right, so all of these previous examples, the numerator was 1, so I didn't really mess with that. But let's take a look at some other examples where we have a numerator other than 1. So if we have a to the 2/3 here, I don't really worry about any of this stuff, but if we have a to the 2/3, I'm going to rewrite that as the cubed root of a squared. Again, the denominator is 3, this becomes the index, and a squared, this becomes the radicand squared. So we can leave the squared in here, or we could just evaluate this and then square it later. It really doesn't matter what order you do that stuff in. So let's take a look at a few examples. I'll try to work them as best I can, and hopefully I'll give you a sense of how to deal with fractional or rational exponents. Here we have 81 to the 3/4. Maybe just try to pause the video and set this up. fair warning, there we go. So I'm going to rewrite this now as the fourth root of 81 cubed. Again, I could put the cube down here, that's fine as well. The fourth root of 81, well, let's see what that is. 81 breaks down to 9 times 9, and each of those 9s break down into 3 times 3 times 3 times 3. Okay, so the answer, the fourth root of 81 equals 3, and then I'm going to cube it. So 3 cubed, 3 times 3 times 3 is 27, and that's going to be our final answer for that one right there. Let me get my eraser out here. I'll just erase all that stuff. Second one, 32 to the 3/5. Again, that's going to be 32, the fifth root of 32 cubed. Okay, again, 32, well, let's do a prime factorization on 32, and we're looking for 5 numbers multiplied together. All right, so 32, let's go 4 and 8. 4 breaks down into 2 times 2, and 8 breaks down into 2 times 2 times 2. So again, we have 5 numbers, 5 2's, all multiplied together. So the answer in here is going to be 2, and then we're just going to cube it. 2 cubed equals 8, and that's our answer for the second one. This third one now, let's evaluate. Now we could, start evaluating this with roots and things, but we really just have like the exponent rules kind of going on, the quotient rule. So let's break this up and we'll see if we can solve it that way. So 48 divided by 3, that's going to equal 16. And then we have our x's. All right, so we have x to the 5/3 minus x to the 1/2. So I'll just write that out. We have 5 over 3 minus 1/2. Now this is a fractional problem. Keep in mind all this right here is the exponent. Okay, so I'm just going to write that up here a little bit bigger. But essentially, we need to have common denominators here. What's the the greatest common, or the least common denominator, the LCD here between 3 and 2? Well, you can just multiply them, and it's 6. So let's make 2 fractions with the denominator of 6. Now 3 times 2 gave me 6, so 5 times 2 is going to give me 10. And then same way over here, 2 times 3 gave me 6, so 1 times 3 is going to give me 3. Now we have common denominators, we'll subtract the numerators. That's going to be 7 over 6. So my answer, if I just clean this up a little bit, get my eraser going, pen, this is going to be to the 7 over 6. And there you go. Essentially simplified. We could flip that x around again, but there's no real need to do that at this point. Okay, so I hope that was useful. Again, pause the video and try to work these out, and there's lots more examples in your textbook or online. If you have any questions at all, just give me a shout and let me know. Thanks.